is AP Calculus, section 2.1, page 5. Today we are going to be working on one-sided limits. See this little superscript up here, this little plus sign? That means the limit of f of x as x approaches a from the right. And when we have this little superscript of a minus sign up here, that means the limit of f of x as x approaches a from the left. And finally, we have the limit as x approaches a in general, that we say that that limit exists and is equal to L if and only if the limit as x approaches a from the left side is exactly equal to the limit as x approaches a from the right side, and both of those are equal to that same number, L. To further explain this idea, let's go ahead and look at some examples. We're going to sketch a graph here for this function. When we look at sketching this, we have f of x equals -2. It's a horizontal line at -2, but that horizontal line is only valid when x is less than 0. So we're seeing that piece. Then the other piece here, f of x is equal to 2. That's another horizontal line at a height of 2, but that's only valid when x is greater than or equal to 0. So we have this piece. And now we can start evaluating the limits. We want the limit as x approaches 0 from the right. So coming this way, toward x is 0 from the right-hand side, we see those y values remaining at a height of 2. Down here, coming at 0 from the left-hand side, we see that those y values are remaining at -2. And this limit from the left side of 0 does not equal the limit from the right side of 0, so we say the limit as x approaches 0 of f of x does not exist. Taking a look at this next one, again, let's sketch a graph. Just putting some tick marks here to make this graph as accurate as possible. When we go ahead and graph this, we have y equals 2x plus 3. That's a line with a y-intercept of 3. Slope is 2. I can't keep going in the positive direction here with a slope of 2 because this line stops at x is 1. Which is right there, and we have an open circle right here. Backing out of this slope, or counting slope backwards, if you will, several times just so I can get a nice accurate line. The next piece here, when x is 1, y is 2. And the last piece, y equals 7 minus 2x. Y-intercept is 7, but I don't want to use that because that line is not valid when x is 0 at that y-intercept. We see that this line is just going to start just past 1. So if we put a 1 in here, we get 5. So 1, 2, 3, 4, 5. Oh, it hits that hole. Slope -2. there's that piece. Once we have this graph, we can go ahead and evaluate these limits as x approaches 1 from the right-hand side. So here's x is 1. Right there is x is 1. Coming from the right-hand side, we see our y values getting taller and taller and taller up to this height of a 5. Coming at 1 from the left-hand side. So this way, 1 from the left, we see our y values. Here's 1 coming, and those y values are getting taller and taller and taller toward a height of 5. The last bit then, that limit as x approaches 1, since both of these are equal from the left and the right side, this limit is 5. One more thing to talk about on this one, I want to know what is f of 1. The function evaluated at 1 is specifically 2. The difference between a limit and a function value value is at a particular point. A limit talks about not at that point, but as we get close to that point. Okay, thank you for joining me on page 5. Please join me on page 6.